Want to call to order the June 7th, 2010 meeting of the Ascension Gravity, District 1 Gravity Drainage District. We have a roll call. Madam Secretary, please note that Councilman Lohr is out of town and Councilman Cullen is at work. If everybody would mind standing, we'll have the invocation followed by the Pledge of Allegiance. In the name of the Father, Son, Holy Spirit. Dear Lord, we ask that you protect our coast. Make all the efforts that are going forward be productive efforts. As we stand here tonight as elected officials, let us stay out of the politics. Let's do what's best for our neighbors and for our country. We ask that you protect us in this hurricane season. Not only the people of Ascension Parish, but our whole coastline. Give us time to get this oil cleaned up before we have any more storms. We ask this in the name of your Son, Jesus Christ. Amen.
Amen.
At this time, also, I just have a special intention. I'd like for everyone to consider the Epps family in their prayers, the times they're going through right now. Mr. Mitch Epps and all his family. We ask that also, Lord. Amen.
Thank you.
I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Right now, I want to announce that we have a public comment period. Anyone wishing to speak on an agenda item, please get with the secretary and you'll be allowed some time to speak. On the agenda, we have no additions, but I want to note that we're going to pull agenda item number 11 tonight until we have more information. We'll move on to item number 4. Right now, the chair would accept a motion for accept the minutes of the May 3rd meeting. We have a motion by Mr. Bell, second by Mr. Todd Lambert. Any discussion? Any opposition? Motion carries. On the chairman's report, I don't have anything tonight, but I do want to announce that we'll get into it a little bit later, that we did, matter of fact, Councilman Todd Lambert went up to Clemson for the witness to hydraulic modeling of the Henderson Bayou project, and I'll turn it over to Mr. Rue right now on the drainage reports.
Yes, sir. I think you should have the summary of work done by the Drainage Department and the parish through May. Also, all your work orders in your district is in front of you, should be there for your review. And I won't go into it since we have a little presentation from CDM on the modeling at Clemson. It can take a few minutes for that. So unless you have some specific questions for us, what's happening in your district?
Yes, sir. Mr. Thompson.
Yes, Bill. I wrote a work order on Jackson Street. Reverend Victor Pettisclaw has some complaints about his house. It's flooded. This past flood, the big flood we had, and those cupboards are pretty plugged up. Could you make sure somebody go out there and make sure they get them unplugged?
We'll give you a status report in the morning.
Okay, because I was at church Sunday and he was complaining about it again, and he was pretty upset because he's worrying about his house flooding again.
Yes, sir. It'll be sent by email first thing in the morning, status report.
Thank you.
Yes, Mr. Todd Lambert.
Yeah, Bill, on the Bird Island ditch, I know it shows 95% complete. What are we missing on that as far as that channel?
You're missing several things on Bird Island. Number one is where the bridges are. We have some bottlenecks because the bridges have to be replaced. Once we contracted out to replace, I believe, about 7 crossings, 6 or 7 crossings. We can do them all at one time, contracted, and we have a little funding issue on that. The main thing, though, is at the end, from Bird Island Road to
Right.
Black Bayou, we have a section, a big section there that we have to enlarge. We have a few permitting problems. We're working through some after the fact permitting. And as soon as we get that in place, we're going to complete that project at the end and should have the funding for the bridges at the same time.
So that's core permitting that
Yes,
we
sir.
need for that? We don't have any problem with that pipeline in that
Well,
area?
the pipeline is going forward with their portion of the,
Okay.
of their modification, protection of the
Okay.
pipeline. Yeah, Shell and the other pipeline will be doing their work probably pretty shortly.
Okay.
But our main problem is the bridges and right at the end, Bird Island to Black Bayou.
One other thing, long reach, outreach, the excavators that we got, that we are leasing now, I noticed they're sitting at the yard. We don't have any projects for them. I'm just guessing my question is, why are we leasing them if we don't have any? I've been seeing them, I pass there every evening and I see them sitting in
Right.
the back there.
Actually, we're doing a couple of big projects that don't need them. And, but we're looking at getting back on the dredging project of some of the major channels. We're trying to get through some delineation of Muddy Creek and delineation and permitting on the Bayou Goudin.
Okay.
And those are going to be the two big projects that we're waiting for, and hopefully we can get to them before too much longer.
Okay, time frame is pretty close, that's why you're keeping?
Yes, sir. Well, again, these are yearly contracts.
Oh, that's yearly contracts. Okay,
Yearly
that was my
contracts.
next question.
No.
Okay.
And it's all set into our funding, and it's hard to send them back, get them back and forth, because
Okay.
it's on a yearly contract.
That was the question I had, whether it was a yearly or, okay. Thank you. That's all I had, Mr. Chairman.
Any other questions for Mr. Root? Go ahead.
Okay, next thing, CDM is here, and I'm going to ask them, my representative, to come up and give a little presentation on the modeling at Clemson for the Henderson Bayou project.
Good evening, board members. We have a short video, approximately 9 minutes, that we took from a recent model test trip that Councilman Lambert and myself and a few other members of the CDM design team took. May 11th, we went to Clemson, South Carolina, to witness the pump intake and the canal hydraulics model. Everything that is going to be shown in the video was exactly what we expected, and the trip turned out to be a big success, I feel. So with that, Lester, if you could play the video.
Okay, we're going to go ahead and do an overview video here of some things we're looking at for the witness test for the Henderson realigned pump station. Right now we're looking at the pump station itself running at a low water level, so we're at elevation 2. And what we've done is we've found some different flow rates that we can operate at different water levels. This is about 450 CFS or so, to look for the exact number. There's no flow through the Runner River gates. We're going to show you some different things here. Right now, one of the modifications that we're discussing is a diversion wall, and we'll be taking this in and out and showing you on the video why we want to have this. This is preventing some debris from tending to want to go during the Runner River condition right into the pump station. We've optimized this corner a little bit here, and we've optimized some of the features of the actual Type 10 inlet itself. But a quick overview of the model. Looking upstream here, we've got a portion of the canal. The bottom bathymetry is simulated. The black that you see in the background is a flow straightening fabric from a well-up style head box. So we suck water out of the pump station side and we reintroduce it back to that big pipe that you see. That redistributes it uniformly across the canal, then it comes downstream. And we can operate the model with the pumps at any flow rate that we want, and also the PVC pipes that you see over on the side are what we're going to withdraw flow to simulate the Runner River gates in operation. So let's go ahead and we'll walk down and we'll take a look at conditions at the pump station. Okay, a little bit difficult to see, but you're looking at the back side of the Type 10 form suction inlets, and we're looking upstream here. We see a series of 3 horizontal pipes. Those are surface vortex suppression pipes. And then on the left-hand side here, you see some vertical pipes. What we're doing there is we're trying to redistribute the flow vertically over the relatively steep ramp. And we can see we'll put some dye on the right side without those pipes in place, and flow's actually going upstream. So you see it going up towards the trash rack here, up that steep ramp. That's typical when we have a relatively steep slope like that, and we anticipated it. The reason it is steep is so that the overall length of the structure could be minimized to minimize the cost associated with it. And then we'll go ahead and add a simple remedial measure on the left side, such as some pipes like this. So we'll put a little bit of dye on this side. Here you see the dye just stays there. It stays all red. That's indicating a large separation zone. On this side over here, we're going to watch, and there the dye heads right towards the pump station. So you see it all going downstream, or towards the pumps. It's all going downstream now, nothing back upstream on that slope ramp. So it's real easy to correct that. We'll put a little dye on the top of the inlet here. We'll show you that it stays attached, nice and stable. We're fully expecting the Type 10 itself to perform well. It's been proven a number of times. What we're really looking for in this model is any issues associated with the approach flow. So once inside the inlet, it looks good. Staying attached on the upstream side real good here. No problems at all. The colored veins that you see are indicating how much pre-swirl or rotation that we've got. They're barely moving. It's well under a degree, so that looks good. A small velocity probe located down here lets us measure the velocity variations around the pump throat where the impeller is. Everything there looks good. So all the conditions at the pumps look great now. We're just sort of remediating some things out in front. So let's take a look at some approach flow conditions from the other side. Okay, here I'm going to go ahead and put a little bit of dye across the front of the inlet. And we're going to show you that we've got all flow downstream. So there's a little more separation now in the corner with our baffle upstream, but it's not really going to be a problem because you can see that once it gets through it, everything still heads right on down. So we've got positive flow in the downstream direction all the way across. Everything there looks good. This baffle up here in this corner is for an elimination of a separation zone that we had there. You're going to see once the dye gets in that area, it kind of works its way right through. So this all looks fine. What we're going to do now, though, to show you for the video is we're going to go ahead and run the run-of-river gates here, and then we'll take a look and show you why we've got this diversion wall upstream. Okay, now we're running about simulating about 2,600 cubic feet per second as a river flow. The pump station has been turned off. We're putting some dye in here now, and you watch this stream, you can see it going pretty clearly right down in past the bulb here at the end of the intake structure entrance. And just a small amount of dye, you see a little bit drift over there. Really, that's probably just kind of some dispersion. But clearly the vast majority of this dye is heading right straight to the gates. That's what we're looking for. We want to prevent that debris from heading right straight to the pump station. So all the way across here, you'll get, again, the greatest percentage is clearly going right over towards the gate structures. So what we'll do is we're going to go ahead and pull this out now, and then we'll show you what that looks like without the diversion wall in place. Okay, we've removed the wall now, and go ahead and we'll watch this dye just head right straight over towards the pump station. So you see it drift right in. Now some of the dye is getting pulled over, but it's very likely that any debris with some momentum is just going to kind of work its way right into the pump station. You see some red accumulating at the front. Here we go again. So any kind of a debris mat or a larger log is just going to go right up into there, and then it's going to be hard to pull that solid debris back out. Where the dye is easily movable, but the bigger stuff is going to go right in that direction. So that's why we're recommending a diversion wall to prevent this from occurring during normal run-of-river operation. Okay, we're putting in a couple floating, neutrally buoyant pieces here. Some of them went by, some of them end up right down into there. So that's what we're concerned about, is eliminating this this mat that may tend to kind of get plugged up together. You see them right in there, and then as they swirl around and twirl, they'll get jammed together, and eventually they'll have a real hard time working their way back out. Okay, we're running the river now up at elevation 4, and pumps are at about 625 CFS per pump. I'm going to go ahead here and show you the diversion wall. We're just holding it in place. You see everything just kind of goes and flows right in there, nice and uniform across there. So the wall doesn't have any negative impacts up at this level. And now what we'll do is we'll go back and take a look around the pumps, and then we're actually going to choke a screen and show you what happens if the screens were to become debris laden or plugged up. We're going to go ahead and put a little dye here and show you now that, again, we're going to see, if you were to stand out there, you'd see a little recirculation, a little eddy form. If you watch that dye, as we move it downstream here, it definitely is all positive flow in that end, so it shouldn't be any debris that wants to accumulate in there. It works its way out. We don't feel that that's enough to make this bulb any bigger or modified out there at all. Okay, what we're doing is here we've got a dye wand, and you can see that dye is attached. It's hard to tell off video in sort of the 2D, but it's all going upstream, just a little bit of bouncing around, and they're not very much at all. This is on the worst part of, right on the angle on the throat, so that looks real good. No rotation at all. We're going to go ahead and block a screen now. You can already see a little bit of a ripple here on the surface. This is the flow rate we've identified to be a max flow at this screen, or at this water level. Now we're going to go ahead and put a little blockage on here and show you what happens. You can see now it's a choke condition there. You can see it all much deeper on the upstream side, and it's actually drawing the level down in the intake on the downstream side. That would be obvious in the field. So you can see this is a choke condition here. We'll pull one of those out, and that choke will go away. Water level comes back up. This is a condition that we use to determine the max flow. So we'll go ahead and wrap up this summary video. We've kind of shown you some different scenarios of screen blockage. We've shown you why we want to recommend some vortex suppression pipes and a baffle. We've shown why we recommend a diversion dike out in front. And we've kind of shown some nice uniform flow in the pumps.
That was the video from the test. Like I said, it went well, and you saw the two optimization the design points that or techniques that they put into the lab to help facilitate the positive flow. So other than that, everything went well, and we've got I guess an update on the status. Where's Robert at? Of where we're at. Unless you guys have any questions with the specific
Comments
the
real
video
quick.
or comments.
Yeah, go ahead, Todd.
Yeah, guys, it was very interesting, very important that we did a model in front of this project, because now we know this project can work. And they had some questions on the debris, which, was proven facts that what we needed to do to direct the debris away from the pumps. I think the pumps are 500-gallon CFMs, but I think they said they're capable of maybe going to 635 or something like that at the pick up some of the capacity there. Also, I think we figured at 8-foot elevation, but that's being safe, so we might be able to get a little bit higher and maybe get a little bit above that 5-year storm also from the showing the model. And like I say, I thank CDM for the invite, because it was very, very interesting, very important to the parish that we get a project that we know it's going to work before we spend that kind of money. Thank you, Mike.
Randy?
Mr. Chairman.
Yes, Mr. Bell.
Okay. Likewise, Mike, I'd like to thank you for this very informative night, very interesting. Thank you and Councilman Lambert for your going up, Todd. Good job. So, thank you.
Thank you.
Yes, sir. Mr. Shake Snyder.
Thank you, Mr. Chairman. Mike, I know, appreciate everything y'all have done on this. I know we've had trouble with the screens, cleaning the screens on the other, the Marvin Brule station. How are you going to have the screens set up where they get, be able to get clean debris and things of that sort?
How we have the design set up now, I'm not, I've seen the
Looks
Marvin
like
Brule.
he's got the same design there.
I don't think the screens are rakes. From what I've talked with the engineers over there, basically the debris is going to, where you've seen that debris boom
Right.
that's directing the debris, it's actually going to go to the bank where you can scoop there. The debris is not even going to be in front of the screens. Most of it, the majority of it.
Yeah.
It's
But I
gonna
mean,
be-
when we do receive debris, how do we clean the screens?
Well, first of all, the screens are designed so that they can have a catenary rake added to them. That was a cost consideration when we started this design, was, to keep the cost low. Right now, it's manually cleaned. If there's
Okay.
any large debris, it's going to have to be manually cleaned by the
fine.
operators.
I was just curious.
We do have some other contingencies to help divert debris, which will be some floating booms with some mesh underneath or some screening underneath the boom that should help move some of that debris towards the gates also. So, but at this time, yeah, for cost consideration, the automatic cleaning, the catenary screen was not included.
Okay.
It can be retrofitted in there, though. It's designed to have that added.
But it's something when we do have, we can just take a machine and just pull it out.
Correct, correct.
Mr. Thompson?
That's what I was gonna ask. Could you remove the screens and just clean them and then put them back?
The screens, I don't know if you'd ever want to remove the screens, but you can reach down and pull the debris up. I'd have to, honestly, I'm not sure if the screens are removable. I don't know that off the top of my head, actually. I apologize.
I've seen screens, well, in the petrochemical industry where you could go in there and lift the screens up and hydroblast them and
Oh,
clean them.
that kind of
put 'em
cleaning. I
back.
thought you meant to remove debris. Yeah, they can be removed, but I don't know if that would be something you would do just if there was debris. I think that's.
Yeah, when
something
it
going in.
stops up, I mean.
Yeah, when it stops up, they can be cleaned. Yeah, that would be something you would do,
Before you start it up the
yeah,
pump
not,
station, yeah.
that wouldn't be very regular to do that, I don't think. Maybe once or twice a year at the most.
They're
Thank you.
actually going to be manually cleaned by an operator, similar to what we do at Marvin Bro Pump Station when one of our rakes go down and is inoperable. We manually remove it with a piece of equipment. Since this is just a limited number of pumps, just actually one pump, 2 pumps here, it's not hard to actually station a man there and remove the large debris as it becomes clogged.
Hopefully, all the large debris, as you saw in the video,
Diverted.
gets diverted
Diverted
and
with
goes
the boom.
through the gates. And if there is some that remains, I think the operators can probably reach it from the bank before the pumps are started up.
Yes, sir, Mr. Lambert.
And far as the way they got I guess the pipes coming across for us to reduce the vortex and the cavitation of the pumps is real critical. Found out that, if your alignment's not good, you got a lot of pressure pushing on your shafts or your impellers, and that's why your bearings and all that, it's not going to hold up. This project showed real smooth flow with very little bit of vane, turning, so it's very crucial that we have the alignment where it needs to be. And I think we may have had some problems with the Marvin Bro because we had some vortex right in front of the suctions of the pumps, but they're addressing that now. But
Yeah, with the
it
old.
was similar to
with
the
old
same.
screen design, they did have, and of course, maybe back then, they did not have the amount of electronic testing for and actually
Right.
determine swirl, so.
I don't think they did any modeling back
Yeah.
then, but if we'd have had a modeling for that previous, before we built them, it would have been a benefit to the parish too.
It's a great asset.
Yeah, it is a great asset.
Sir, Mr. Dempsey Lambert.
Yes, I'd also like to thank everyone involved with this modeling. I'm glad it's been 25 years since the Prairieville, Galvez area has been waiting for this project, but it looks like all the kinks are going to finally be worked out, and a good job. Thank y'all.
Just to, one last thing to wrap up, the report is, right now, we're approximately 85% complete. We're on schedule for the, as originally submitted, so we're getting towards the end here. We will have a submittal for you guys to look at, whoever's interested, when we get closer, probably to about 95%, for any last comments that you guys want to
You
take a look at
definitely want
things.
another look at it when you
Yeah.
get into the 90s, and also, like I said, you got it about 85% complete, and we're still holding on to the budget, right?
Yep, we are on budget and on schedule at this time, so everything looks good.
Thank you, sir.
That's it.
That concludes our report for tonight.
Thank you,
Thank you.
guys.
Thank you, fellas.
Thank you.
All right, Mr. Rue, you got anything else? That's all your report?
That's all.
Okay.
One thing, Mr.
Yes,
Chairman.
Mr. Dempsey Lambert.
Back up just a second. I know Mr. Lore's not here tonight. Bill, on that Man Shack, Muddy Creek and Lake Harbor, it delivered the shoring today.
Material's been delivered today and work is the project will be manned tomorrow, beginning of project.
All right. Thank you.
Anything else? All right. Let's move on to agenda item number 7, authorization to join LECA, SmartNet, GNSS Reference Network. Mr. Rue?
Yes, sir. What we're doing here, we're asking authorization for the parish president to enter into a cooperative endeavor agreement with Leica Geosystems Incorporated to become a host in the SmartNet GNSS network as per terms of the conditions set forth in the agreement, contingent on legal review and approval. We've gone in depth with the attachments, reasoning this decision, and we think it's a good deal for the parish. We can get out of it at any time, but it actually saves us $4,300 a month and give us access to a statewide and eventually southern United States system of core stations to benefit our stations.
I'll offer that motion.
We have a motion by Mr. Thompson, second. Second by Mr. Bell. Any further discussion? Mr. Rue, real quick, this will replace the other agreement we've had with...
Yes, sir. They've been doing some maintenance work because we contracted with them to put in our core system, and this actually saves us. We don't have to pay a maintenance agreement because they will maintain it. The only thing that we are obligated to do is something breaks, a mechanical part of the core station breaks, we pay for the cost of the part, but they will pay for updating and maintenance of all the systems at no cost to us.
Okay, and if we go forward, when do we expect to be online?
Well, they're trying to get all of the state, or most of the governmental and local agencies into this system. Once they get most of the agencies into it, then they will activate it. And that's part of the contract, that we really are not obligated to anything until they activate the whole system. But they have to get a commitment, like we're doing tonight, from a number of places before they can activate it.
Okay. Any further discussion? Any opposition? Motion carries. Move to agenda item number 8, contract between Ascension Parish Sheriff's Office and East Ascension Drainage District for inmate labor. Mr. Rue, this is what we got here is our standard. We're renewing the contract, and we got a 5% increase.
It's a renewal,
Right.
and the compensation to the officer that is in charge of the inmate crew is changed from the last contract, and that's why we're bringing it to you for acceptance. It is a renewal with a compensation increase.
So moved,
Chair.
Second.
Motion by Mr. Bell, second. Lord. Mr. Valentine. Discussion. We're, this is basically the same rate that we got with the Ascension Parish Sheriff's Office. It's just their rates went up, so we just staying in line with, right?
This, the new compensation schedule is based on the same thing they have for their deputies that's
Sure.
in the school system. It's the same compensation package that the school pays for their deputies.
Good deal. Any other discussion? Any opposition? Motion carries. Move on to agenda item number 9, acceptance of low quote TMC contract installation of vehicle gate barriers and controls, Marlboro Pumping Station. Mr. Rue.
Yes, sir. We're asking for a motion to accept the low quote of $12,678 from TMC Contractors for the installation of vehicle gate barrier and controls at Marlboro Pumping Station.
Motion.
Second.
A motion by Mr. Thompson, second by Mr. Todd Lambert. Any discussion? I just want a clarification. We talked about it earlier that this gate, we have gates locked, and that and then this thing will be accessible to only a limited number of people. Not that if we when we put this system in place, it's going to save us on manning the station.
The whole idea is to eliminate a lot of the overtime that's being worked out there. Right now, it's at 24/7. We're looking at reducing the manning of the pumping station to 7 days a week during the daylight hours only. But we have to have the boatway open whenever we're not there, because that preempts any other conditions for vehicle traffic. You have to have the boatway open at all times, or available to be open for boat traffic. Like this, we can leave it open and have the controls where limited authorized personnel can unlock the gate, go through, lower the gate at the boatway to gain vehicle access, and then open it back up for boat traffic. And that's only when we don't have it manned, which is only at night. And every other time it can be secured because of the, as you know, we just had the whole pump station, complete pump station enclosed, so that can be secured. We have security gates on each end of the pump station, which will be locked up. And also, we're working on right now, getting quotes on actually putting security cameras on the gate and all gates at the pumping station with a security system. So it will be secure when people are not there.
So basically, that when we leave at night, it'll be open for the boat traffic.
Right.
The road gates will be locked and only limited access, people with the pipeline and people, landowners on the other side that normally need to get in.
And that would be
leases there.
really very
limited.
few times that that's going to be necessary for them to access through there at night.
People on the river can't come in and try to access that. Thank you, sir. Yes, Mr. Thompson.
Yes, Bill, when are we planning on cutting the workers back to daylight hours?
As soon as we get all of these conditions in place.
So as soon as you get security cameras and the gate in
Right.
place, that's when it's going to take place?
That's it.
Thank you. That's all.
Any other discussion? Any opposition? Motion carries. Move on to item number 10, HMGP items for consideration. 10A, authorization to bid 15 HMGP elevation sites. Mr. Rue?
Yes, sir, and this is going with the elevation grant from Homeland Security, FEMA grants, and these are sites that's been in the process of getting approved for at least a year or so. We finally got more money to be able to bid these sites out, and we're asking authorization to proceed to bid.
Yes, legal, what we're looking for here, a vote on one and then vote on the other, vote on both of them together?
Vote on one and vote on the other one.
Huh?
We need to vote on A
Each of them
first.
separately.
Yeah. Okay.
Motion, Mr. Chairman.
We have a motion by Mr. Dempsey Lambert,
Second.
second by Mr. Kent Shake Snyder. Any discussion? Any opposition? Motion carries. Go on to agenda item number 10B, authorization to request extension of 1 year to the period of performance on project 1603-05-0001, 1607-005-001, 1603-005-0002.
So moved, Mr. Chairman.
We have a
Thank you.
motion by Mr. Valentine,
Second.
second by Mr. Shake Snyder. Any discussion? Any explanation? Mr. Rue, you got anything on this, or y'all good with it?
Well, we explained it in the handout, I guess,
Yeah.
to you, and it's a very simple. We just formally have to request extension. There shouldn't be any problem, but we need authorization to do that.
All right. Any further discussion? Any opposition? Motion carries. We'll move on to item number 12.
Motion adjourned, Mr. Chairman.
We have a motion by Mr. Todd Lambert. Can I get a second? Second. Mr. Benny Johnson, we got a second. This meeting is adjourned.